In this lesson, I'm going to go ahead and talk about assignment 3 with logistic regression. Make sure that everyone is on the same page for how we're going to go about solving assignment 3. So if you open up the logistic regression output and question file, it's an Excel file, you should see that there are 4 tabs. And in those 4 tabs, if you look at questions to get started, this is going to be looking at Chapter 9. Okay, so you're going to be using Chapter 9 to answer these questions. Very first question is talking about the mortgage file. Mortgage file is one of the files that's already in the module. So look at the mortgage file, open that up, and look at the 3 variables and see what they mean. Okay, so all you need to do there is in the space, type in the variables and what they mean. An explanation of that you're going to be able to see again in Chapter 9 of the textbook. Now on question 2, we're beginning to move from a linear regression to a logistic regression. And so when you're looking at the textbook, example 9.1, which I think is on page 316 for you, example 9.1 is looking at this mortgage data, but it's looking at it from a linear regression standpoint, okay? So linear regression approach is in 9.1, and then example 9.2 switches to logistic regression. And the difference between linear and logistic is that logistic regression starts allowing us to think about outcomes that are either a go, no-go, a binary. In the case of a mortgage, did the person get the loan or did they not get the loan? So logistic regression is a different mathematical transformation, and the reason they call it logistic has nothing to do with supply chain. Instead, it has to do with logarithms. Okay, so question 2 is absolutely the example 9.2 in your textbook. So that logistic regression equation that you're looking for really comes from table 9.4 on page 319. It shows you exactly how to, or it shows you the coefficients associated with it. Very similar to the linear, the way that it's reported, or the linear regression. However, the way we use the data to interpret these results is very different than the linear. That's what question 3 is asking about. It's asking you to come up with a probability of a loan with a 25% down payment with a 35% income to loan ratio. You will see the exact data for being able to calculate this on solution B, example 9.2 on page 319. So again, that should get you really close to being able to finish off question number 3. Next, questions 5 through 8 are looking further at logistic regression output data and interpreting the results that come out of it. If you open, and you already have it open, the parole file is the logistic regression output and questions, and it says for question 5, it's asking you, if a man is more likely to create a crime or a woman. I recommend opening up the parole file. In the parole file, you will be able to see the data that's associated with it. One thing that you'll notice is that there is a dummy variable there for man. Man is listed as a 1 and female is listed as a 0. So when you're answering question 5 and you're looking at the logistic regression output, if you look at the coefficients, okay, again, logistic regression, what happens in logistic regression is we take the data, all of the data, we separate it into different groups. We have a training set where we use a portion of the data to train it. Then we take a portion of that to verify the results. And then the last one, we use a test group and determine what the our model that we've developed, how it compares to the actual results that we get out of a test group. So that's the way that we set it up. Here's what happens with the model that was developed. With the model for parole, it says that we have an intercept, an age, and male. Age is a negative estimate, which would mean that the chances or the likelihood that someone is going to create or is going to perform a crime if they've been paroled is negatively related to their age, okay? Again, the older you get, the less likely you are to create a crime once you've been paroled. However, look at a male. This is positive. So therefore, question number 5, you can answer that just based off of that, the fact that it is positive for men. All right, so I'll let you go with that. The next question is predict the probability a 30-year-old male will commit a crime if paroled. You have the equations, or the coefficients for your equation. You also know based on example 9.2 and the way you came up with your answer for question 3 that you will be able to predict this now. Question 7, based on the training score, how frequently does the model predict a crime when a crime is actually committed? All right, based on the training score, how frequently does the model predict a crime when a crime is actually committed? Now let's look at the training score. The training score gives us a what we call a confusion matrix. Confusion matrix says that I have held out a certain amount of my data, and I have tested this model to make sure the way that it works out. All right? It's saying that if I predict no crime is committed, 12 times the actual outcome was correct. However, once, if I predicted no crime, 1 time the person really did create a crime. Same goes here. If the model predicted that a crime would be committed, 4 times a crime was committed. However, 3 times it didn't predict a crime. And so the confusion matrix here is set up from I predicted a crime and a crime was committed. That's 4 times out of a total of 7 opportunities. All right? So hopefully that's beginning to get you to see what's going on there. Question number 8, using the confusion matrix once again, is how you're going to do it. And the reason for having these confusion matrices or matrices is that oftentimes whenever I'm building a model, I really do worry about, does this model, if I predict nothing's going to happen, what kind of an error rate do I have on it? If I predict no crime is going to be committed, I'm only wrong 7.7% of the time. However, if I predict that a crime will be committed using this model, I'm wrong almost 43% of the time. So again, everything that we're trying to do right now is we're trying to create models. Some models are useful, some models aren't as useful. And what we can see from this logistic regression, sometimes they are useful in predicting when no crime was predicted or when a crime was predicted. So hopefully that gets you through this. Hopefully it gives you some direction on how to go through these questions. You can answer all these questions right in Excel and load your entire Excel spreadsheet up to Canvas when you're through. All right, thanks and good luck.